In this video we will cover the basic rules of linear perspective. Knowing these rules lets us draw objects in two dimensions in the same way that we see them. If you want to be able to draw well, it is important to know these rules. The subject of linear perspective can be quite elaborate and technical. Fortunately, it can be simplified to a set of simple rules that are sufficient to draw well. In this video, we will lay the groundwork for this subject, and in later episodes, elaborate on it with drawings of more complex shapes. The first rule that we will cover is very simple and intuitive. Objects that are closer appear bigger on paper. Take a look at the box drawn frontally on a table. What is the distance between you as the observer and the two sides of the box? The distance is the same, and the sides are drawn to be of equal height on the paper. Now take a look at the second picture. This time the box is rotated and the left side of the box is closer to the observer than the right side. Notice how this time the line representing the left side of the box is longer than the line representing the right side of the box. For now, just remember this rule, and while drawing, start paying attention to what is closer and what is further away from you, and adjust the dimensions of the drawn object accordingly. The next principle that we will discuss is, all lines that are parallel to each other converge to the same point. We will call such points convergence points. Let's draw the imaginary lines that are the continuation of the sides of the box. In the drawings you can see that all the lines that are parallel to each other converge to the same convergence point. In addition, all convergence points are on the same imaginary line. We will call this line the horizon. The convergence points need not be inside the paper, like in this case. They may be far beyond the sheet of paper. The horizon is infinite. You may ask, what is the horizon and how to find it? The horizon is an imaginary infinite horizontal line on the level of the eyes of the drawer. When you start a new drawing, it is very important to be aware of where the horizon is. Take a look at this drawing of a house by the beach. Where do you think the horizon is in this drawing? To answer this question, you simply need to imagine where the artist was standing and from which angle he was looking at the house when this picture was drawn. In this case, the artist was standing on approximately the same plane as the house, and he was looking straight ahead. Not surprisingly, in this case the horizon will be at the same level as the sea in the drawing, which is the natural horizon we are used to. Another way to check this would be, for example, to continue the sides of the roof of the house and see where they converge. Remember from the previous sections that all the parallel lines in the drawing will converge to points on the horizon. Now, what would happen if the person drawing the house remained standing on the same spot? In other words, the horizon would remain at the same place, but the house would be placed on a hill. Take a moment to examine the differences between the two drawings. Notice that if you continue the imaginary lines from the roof of the second house, they will still converge on the horizon, that is on the level of the sea, as before. Notice how lifting the house affected the shape of the roof, for example, and how the lines are now directed with a sharper angle towards the horizon. Now, let's see what would happen to the drawing if we were looking at the house from a higher point. In this case, the horizon is still on the level of the sea, and we are looking straight ahead, but the house is below us. Continue the imaginary lines of the sides of the roof. You will see that they are still converging at one point on the horizon. Next time when you draw, start by understanding where you want the horizon to be. Remember that when you are drawing from observation and not from your imagination, if your head moves, the horizon moves with it, which means that when you start drawing, you need to decide about the angle of the head with which you are drawing. and return your head to the same spot each time you look at the object that you're drawing. As an exercise, do the following. Find some drawings or photographs. Preferably it should be either landscape or interior images, as they demonstrate these concepts best. Imagine where the horizon is in each image. Then find some lines that are parallel. There are infinitely many such lines that you can find. It should not necessarily be some real lines, like the edges of a building. It can also be some imaginary lines, between objects that are arranged in repeated patterns, for example. See how all these groups of parallel lines converge to some convergence points on the horizon. In this part we will summarize the points covered so far, using a drawing of a room. First, notice how distance affects the size. See how the sides of the window and the door that are closer to us are bigger than the sides that are further away. Next, notice the convergence of parallel lines into a single point on the horizon. This type of drawing, made when the viewer is standing directly in front of the subject, is called a drawing with a single point perspective. Does single point perspective mean that there is always only one point of convergence, like in this drawing? The answer is no. Look at the picture on the right. You can see that it is exactly the same as the one on the left, just that now the door is open. This time the door is in a plane that is not parallel to the side walls, which makes the edges of the door not parallel to other lines in the drawing. And of course, this creates a new point of convergence, as you can see. Now think, what if we open the window as well? Would that create an additional point of convergence? In which case, will this new point of convergence be exactly the same as the point of convergence for the open door? As an exercise, try drawing the room you are in now. Remember to start with the horizon, and also decide the viewing angle from which you are drawing. Remember that when you move your head from side to side or up and down, the image changes with it. In order to estimate the angle between the different lines in the room, extend the pencil in front of you, so that it is parallel to the horizon. Notice the angle between the pencil and the line that you are drawing. Start with the walls, and then add the different objects that are inside the room, like tables and chairs. Don't forget to notice the relative distance between the objects and yourself. Look for parallel lines, real or imaginary. Calculate the convergence points for them. Try changing the location in the room and redraw the room. Do it while seated and from a standing position at the same place. How does standing up affect the horizon, and in turn the picture you get? This exercise is not as simple as it sounds, and if you have not done this in the past, it may prove to be very challenging. Don't give up easily. Finally, we want to talk about the concepts of 1, 2, and 3-point perspective. A simple way to think about these concepts is to think about the drawing of a box. When we draw a box frontally, like in this case, there is a single point of convergence, as you can see. Drawings done in single point perspective are typically drawings of streets or roads drawn from the middle of the road. Look on the internet for single point perspective images to better understand this concept. 2-point perspective is when the box is drawn from an angle, like in this case. 2-point perspective is a simplification. It assumes that vertical lines are parallel to each other and do not converge. Can you see the difference now? The third box is drawn in a 3-point perspective. This is closest to how we actually see the box. In this case, there is an additional point that is not on the horizon, and to which the vertical lines converge. You can see now that a single point perspective drawing is actually a special case of a 2-point perspective drawing, because in both cases the vertical lines don't converge. Although three-point perspective is closest to the way we perceive the world with our eyes, in reality, the third point is rarely needed, and the simplification of two-point perspective is enough to give a realistic impression of the drawn objects. The exceptions would be drawings of tall objects, like buildings, or drawings in which we want to explicitly emphasize a sharp angle, for example. We suggest that you ignore the third point in the beginning. That's it for this episode. We hope that you've learned something from it. Knowing the rules of perspective is crucial to understanding how to correctly construct your drawings. With time and practice, you will be using these principles intuitively.